Hi, welcome to Math Time with Mrs. Depperschmidt. Today we're going to examine two strategies for determining whether an answer you've calculated is reasonable or close to correct. We're calling that reasonableness. One strategy we'll work on is rounding to help us determine reasonableness. After that, we'll use front-end estimation to determine reasonableness of an answer we've arrived at. First off, consider this problem about walking steps from our classroom. If it's 287 steps to walk to the office, then 193 more steps out to the carpool lane, how many steps will a person have taken altogether to travel that distance? When we calculate, it doesn't matter if we've done it with our brain or on a calculator, the answer we've come up with is 480 steps. But now we'll use rounding to decide whether that answer is reasonable. We'll round to the hundredths place, which means you only think about the hundredths digit in each number. If 287 is rounded to the nearest hundred, we get 300. That's the closest hundred to 287. It's quite a ways away from 200, but it's close to 300. Also, we'll round 193 to the hundredths place. 193 is closer to 200 than it is to 100, so rounded off, it's 200. It doesn't take very long to calculate the answer once we've rounded to 100. The rounding off answer we come up with is 500 steps, which is quite close to the 480 steps that we calculated in the beginning. That tells us that our answer is reasonable. It might not be exactly correct, but it's a very reasonable, close answer. We're probably right if we get that close. Okay, that strategy is rounding, and we've rounded in this situation to the 100ths place. The next problem we'll discuss involves the number of seconds we've spent on the read and ride bicycles. We'll use front-end estimation to decide whether our calculation is reasonable or not. All right. With front-end estimation, you only look at the highest digit in the number, and you ignore the rest of the digits. So to check our calculations here, we're going to make an easier problem by ignoring everything but the front end or the first digit. That's why this is called front-end estimation. Let's imagine that we were on the read and ride bicycles for 6,253 seconds last week. But this week, we were only there for 3,650 seconds. We wanted to calculate the difference in our time, the number of seconds on the read and ride bicycles. So that's a subtraction problem when we're asking for a difference. How much more time was spent the first week than the second week? And our unit will be in the number of seconds we were actually on the seats of our read and ride bicycles. To use front-end estimation for this, we will only pay attention to the first digit in both numbers. We'll use the 6,000 for 6,253 and 3,000 for 3,650. It's quick and easy to do that calculation in our brain, and we come up with an answer of 3,000 seconds. If we look at that side by side with the actual calculation, you'll see that it's quite close. Our actual answer was 2,603 seconds. If you're only thinking about thousands, that is closer to 3,000 than it is to 2,000. So our front-end estimation tells us that our real answer is reasonable. It might not be exactly accurate, but it's a reasonable answer, and it's probably close to right. That's how front-end estimation works. We'll work more at school with rounding and front-end estimation. I hope you are having a great day. Please be kind. I'll see you at school.